Your ChatGPT prompt or query uses roughly 10 to 15 times the energy it takes to run a Google search. And this is just for text generation. Video generation is far more demanding. Every time you ask ChatGPT a question, servers spin faster in a data center, more energy is consumed, and more code data leaves its natural place. Your prompt result has a cost. If AI came with a warning label, it would read, use responsibly.
Hi everyone, my name is Chika and this is Syntax and Script.
Growing up, I remember TV campaigns on efficient energy use by switching off gadgets and light bulbs when they are not in use. But unfortunately, no one is telling us to do the same with our prompts. AI companies are so busy marketing their products and competing with each other to care. And since they are not ready to start having these conversations, we have to do it ourselves. According to OpenAI CEO Sam Altman, a single ChatGPT prompt consumes about 0.34 watt-hours of electricity, which is just enough to power a high-efficiency light bulb for a couple of minutes. And of course, a few drops of water because AI data centers use water currently for cooling. This statement, which might be a gross underestimate of facts, and as such doesn't sound like much because AI companies don't like disclosing their data. But even if we assume that this is correct, multiplying these little costs by the millions of queries that ChatGPT has to handle daily will make the numbers very staggering. For context, your ChatGPT prompt or query uses roughly 10 to 15 times the energy it takes to run a Google search. And this is just for text generation. Video generation is far more demanding. LLMs or large language models like ChatGPT or Gemini are AI models trained on massive amounts of data to generate human-like responses. When you hit send for an AI prompt, the LLM will analyze your prompt, likely using natural language processing, and generate a response based on the instructions that you give it. It's not just pulling information from a database. It is running a complex neural calculation on thousands of GPUs in a data center. This is the simplified version of what actually happens, and this costs a lot. However, the real cost sink happens during the training of these AI models. The training of GPT-4, which is not even the recent ChatGPT model, reportedly cost over $100 million. That of Gemini cost between $30 and $191 million, even before considering salaries. Now, according to Epoch AI and AI Research Institute, salaries can account for 29 to 49% of the total cost of building LLMs. So let's break down these costs. There is, first of all, the computational power, which are the GPUs and the TPUs used for the training and processing of our queries, and they don't come cheap. They cost thousands of dollars, and they are the bare hardware essentials that are needed for the training. Then there is data curation. LLMs require massive amounts of data for proper training, and a team of highly trained data scientists work on data acquisition and cleaning to obtain high quality data sets for the training. Like, just think about how much content they have to scrape from the internet, from books, from websites, any source you can name. And then you have to check this data for biases, copyrighted stuff. Then they also have to make sure that they don't run into legal troubles while acquiring the data, even though recent news on copyright infringements by AI companies is now making it seem like it is legal to trespass on people's content. Anything for AI. Then there is the engineering and the deployment. Building and deploying LLM takes another team and infrastructure effort, including the design of the model, training, testing, research funding to improve the models, and even lawyers. And these are all salaries that need to be paid. Then there's the maintenance. Once the model is deployed, it requires continuous maintenance and updates based on user feedback. This is an added cost. Now, we've established that it is capital and human hours intensive, and these costs are growing exponentially with the evolution of AI capabilities. The cost of training frontier AI models have grown by a factor of 2 to 3 times every year for the last 8 years. If this trend continues, we're talking over $1 billion per model by 2027. So This brings us to the controversies surrounding the costs of the training and the data centers where this AI's processing power is physically located. There have been accusations of encroachment and concerns about land, freshwater, and electricity grid pressures from AI data centers. All of these resources are limited resources, at least on Earth. Think about this. The water used to cool data centers is fresh and often pulled from the same sources that feed farms and cities. A single hyperscale data center can use up to 1.5 million liters per day. Places like Northern Virginia in the US host almost 600 data centers. 600. The highest concentration of data centers in the world. And even though the water returns to the water cycle as rain, it may fall in areas where it cannot be used as potable water. And even a closed loop system that reuses the water comes with its own challenges. And then dumping the water back in the source harms water-dwelling plants and animals, and even the ecosystems that support them. So the water requirement for AI data centers is putting massive strain on water supply for communities where they are located. Then there's the large carbon footprint from the training phase of getting the LLM ready to use. Training large models can emit hundreds of tons of CO2, and AI-related emissions are expected to grow 11-fold by 2030. Now, in spite of these concerns, the AI industry is still booming. And because AI requires massive compute power, top tech companies are pouring billions into building more data centers. However, they are finding that getting land to site these data centers is becoming increasingly difficult because communities don't want these problems and they don't want these massive electric hubs near them. Energy-wise, the International Energy Agency says that data center electricity demand will double by 2030, which will be the equivalent of Japan's current energy consumption. These AI costs are not only affecting electric grids, they're affecting local communities in other ways because let's take, for instance, the case of XAI's Memphis data center pollution allegations, where the local community is alleging that XAI has installed and operated at least 35 combustion turbines and other sources of air pollution at their Colossus site. What is the industry doing about these problems? To mitigate the water resource strain, big tech companies have started exploring water-free liquid cooling techniques for data centers. However, at the time of filming this video, this solution has not yet gained widespread adoption. Some are still using air cooling, which is very expensive. For electricity, companies like Google, Microsoft, and Amazon are eyeing nuclear energy as a clean and scalable solution. And yes, nuclear energy might actually be the only solution to this energy guzzling AI problem because it is a highly efficient source of energy, but it doesn't come without its own baggage. Nuclear energy generation creates radioactive waste that can remain dangerous for tens of thousands of years. Right now, Finland is the only country with a permanent disposal solution, which is to bury the waste 400 meters deep in the air. Everywhere else, nuclear waste is stored temporarily in decommissioned nuclear plants or entombed in steel and concrete, which is very expensive and safe for now until it can be moved to a permanent disposal site or something goes wrong. So, where does all of these problems leave us with AI advancements and needs? First off, it is easy. It's very easy to forget that behind every clever AI answer is a chain of computation, infrastructure, human teams, and environmental impacts. Every prompt you type leaves a footprint, and it will be much better for big tech companies and governments to take more responsibility for AI. But AI responsibility is actually on all of us. We don't need to stop using AI. We won't. We just need to use it smarter. And you can contribute to your quota of emission reduction by doing these things, by being more concise with your prompts, batching your queries instead of, firing off 10 in a row, or choosing lighter AI models when you have less compute-intensive queries or prompts to process. Now, for consumers like me, this can mean using Perplexity AI instead of ChatGPT if what I'm querying is not something that requires an in-depth answer. But for the more technical AI prompters, I've linked an article by Open Data Science Community on some of the best lightweight LLMs in 2025. Finally, and hopefully, with advancements in technology surrounding AI, we will be able to fully harness the power of AI without further harming the planet. I mean, AI has already set us back with our sustainable climate goals. But if this is left unchecked, some of these strains on our scarce resources can lead to far-reaching effects that generations after us will have to settle. Thanks for watching till the end, and leave a comment on your thoughts about AI and how we're using it, what you think the future will look like. Don't forget to like, share, and subscribe so that you can see more of my videos.